Hi, I'm Timon Sloan with the Open Networking Foundation, and it's my pleasure to welcome you to this live keynote session featuring Turk Telecom and ONF. First, I want to thank our sponsors. The financial support we receive to help produce today's webinar and the 20-odd on-demand talks and demos that together make up this virtual event would not be possible without the support from our community. I want to specifically thank AT&T, Vector Data, Radisys, and the Open Compute Project for helping to support today's event. Now, onto our program. We're very excited to have Turk Telecom with us today. Turk Telecom has been an early adopter and a strong proponent for building solutions based on the principles of SDN, disaggregation, white box, and open source. And we are very fortunate to have the technology team from Turk Telecom Broadband program here with us today. So with us today, we have Suleiman Shimon. Suleiman is the Fixed Access System Architectural Manager at Turk Telecom. And joining Suleiman, we have Jimal Suyu. Jimal is the Fixed Access Senior Architect at Turk Telecom. Suleiman and Jimal will together are working explicitly on Turk Telecom's SEBA program and deployment, so it's great that they can be here with us today. And leading off today's webinar, we have Saurav Das, VP of Engineering with ONF. In addition to his role of engineering, Saurav is the architect of both the SEBA and Volta projects and is widely credited as the principal technical visionary in the SEBA and Volta communities. So with that, Saurav, please take it away.
Well, thank you very much, Timon. Okay, so today I'm going to give you an idea about how SEBA and Volta projects have evolved in 2020. We're actually starting from the last quarter of 2019, and then give you a taste of what is going to come in the rest of the year. Okay, so if you don't have a huge background in what we are doing in the SEBA project, I'm going to spend maybe 2 or 3 slides to just give you an idea about what we're talking about. So the rest of the presentation has some context to go by. Okay, so typically, if you look at residential broadband access, this is the picture you would see, right? So we're talking about passive optical networks, PONs, that are typically used for fiber to the home or fiber to the building networks, where in a telco central office you have your optical line terminal, which has several PON ports, and each of them sustains a PON that goes through a passive optical network, your optical distribution network, to ONUs in residences. The same PON can be also used for other, say business services or maybe mobile backhaul and so on. But typically at the residence, you have an ONU and then backed up by a residential gateway. Okay, and upstream from the OLT, several such OLTs are then going through an Ethernet aggregation switch and then ultimately to a specialized router we call a BNG. That other than the job of routing and connecting to the backbone network, it also performs a bunch of subscriber level services like hierarchical QoS and lawful intercept and so on. So this is how a traditional residential broadband access is built today. And what we do in the SEBA project is actually use, fundamentally it's based on, the principles of SDN, the principles of disaggregation, on white boxes, use the merchant silicon and SDN, core SDN principles. So the idea is that we take these 3 pieces of equipment over here and replace them with 3 different projects at the ONF, right? So the OLT is disaggregated and replaced with some very simple sort of pizza box style OLTs, which only have the MAC and 5 layer, but all the control software in an SDN way is pulled out of the box and managed by the Volta project, right? And we do the same thing with the Ethernet aggregation switch with the Trellis project. And then the BNG with what we call SDBNG, right? Or virtual BNG that manages subscriber services. So in a nutshell, this is what SEBA does, right? And to give you an idea about what it looks like on a picture, So again, this is the hardware. You have your residential gateways, your ONUs are the homes going through an optical distribution network to, say, white box OLTs in the central office. These then connect to either one or two switches. Also white box switches, could be also an entire fabric. But the thing is that it looks like a data center. So now your white box switches are also connected to these compute servers, and just because of the location of the telco central offices being very close to the end user, the subscribers, you can think of them as edge compute servers, right? And then that connects to the backbone network. And so in these edge compute servers is where all of our software stack runs. So here's where you see the three projects that I was talking about. There's Volta, and Trellis and SDBNG, but because these are all SDN-based projects, they have an inherent dependency on an SDN controller, which we use ONOS, which is another project at ONF, and then a collection of applications that are, sort of Volta-based applications that are managing the PON with the help of Volta. There's Trellis applications that are managing the switches and almost, an entire fabric if you need it to be. With the help of Stratum, which is another project at ONF, which is a Switch OS project. And then there is SDBNG, and then there are many options for doing BNG implementations inside the pod. But one of the options is to do it, to add BNG functionality where the user plane is in the same switches that Trellis manages. So these SDN-based projects are then complemented with what I call the network edge mediator. It's actually a collection of software over here that is responsible for the orchestration of all the software and hardware inside the pod, and FCAPS functionality, which is really important for service providers. And also presenting this unified interface with which you can connect to different operator backends, right? Operator OSS, BSS systems. All of our software is cloud native. It's containerized. It's managed. It's basically Docker containers that are managed using Kubernetes, installed, removed, lifecycle managed using Helm charts, right? So this, in a nutshell, is a description of what goes inside a SEBA pod. But they're very important to understand that SEBA is modular, right? Just because I show this description of SEBA doesn't mean that everything over here has to be used. Operators can choose to use parts of the SEBA pod and replace the other parts with other choices. So currently, the focus of the project is very much on the Volta project and its use of ONOS and the apps meant to be used with Volta for PON management. So giving you an idea about what that stack looks like. So again, you have your ONOS SDN controller with the applications that are meant to be used with Volta. This is what we refer to as a Volta stack, the things that are in color, right? So you have ONOS talking to an OpenFlow agent, which then talks to the Volta core. The Volta core supports APIs for programming and for management of the OLTs and ONUs. And then the core talks to southbound adapters that ultimately talk to the OLTs and ONUs. So there's a lot of detail over here that we're not going to deep dive into, but the idea is that there is a common control and management framework that Volta provides and that is shared between all OLTs and ONUs, and you can mix and match OLTs and ONUs from different vendors. That's something that actually traditional PONs don't offer. And very importantly, Volta provides, it provides an abstraction for the PON. So it hides a lot of lower level details about PON management, your schedulers, your queues, your TCONs, your gem ports, the use of OMCI to talk between the OLT and ONUs. All of that is hidden from the SDN controller so that the applications that you write over there are very simple and are basically running on the abstraction that this entire PON has been abstracted as a simple Ethernet switch. So that in a nutshell is all about, SEBA and Volta, and how our focus these days is on this particular stack and getting this ready for, for production deployments at Turk Telecom, at Deutsche Telekom, as you had heard yesterday. In fact, for the last 3 months of last year and the first 3 months of this year, or a 6-month period, the SEBA Volta community went through a surge where, there were about 40 or so engineers in 10 plus organizations that were working together in a very concentrated way to help this stack reach sort of production readiness. So to give you an idea about what we achieved in the surge, so as I mentioned, we had about 40 or so developers over 10 organizations, and the way to manage this team spread across multiple companies, spread across time zones in the world, the best way to manage this was to come up with the concept of brigades and break up the teams into smaller teams, each team having a very concentrated task, a very well-defined task, and drive that task through to completion. So there's typically a mentor from ONF or someone in the Volta, SEBA Volta TST that is managing each brigade. And then there are contributors from several companies. And each brigade, as you will see in these charts, made terrific progress in these 6 months. So we started out in October and ran October of last year and ran through March of this year. And as you can see about the rate of issues created, which is in red, and issues resolved, which is in green. And in almost every case, some of them even dramatically so, in almost every case, you will see that there is a big difference in the work that was done during the surge compared to the work that was done before the surge. So topics, of course, range from stabilizing the code base, or working on the software that goes inside the OLT, or implementing features like multicast and multi-decont, which is used very much by Turk Telecom, or working on scale, which I will talk about a little bit later. Test automation that we at least at ONF we focus a lot on, and you will hear about that later as well. And of course, FCAPs, which is a big deal in SEBA and Volta. To give you a highlight, we had actually over this period of 6 months, we had about 80 contributors, sort of half of which were from this surge team that we had put together and was working on this search, and half of it was other people in the community. And you can easily see that the search team resolved all the 86% of all the issues. And to give you a breakup of the teams within the search team, you can see we had some very healthy contributions from a number of different organizations. One more slide to give you an idea of where we are in terms of the releases. Before the surge started, we had Volta 2.1 released, which over a 6-month period, resolved 274 issues. And during the surge, we had 2 other releases. In the first 3 months of the search, we were ramping up. Nearly half of the people in the search team were new contributors, so it took some while to ramp up. But even in that ramp up time, we resolved almost as many issues in a 3-month period as we had done in the previous 6 months. So you can already see the effect of the surge there. And then in the first 3 months of this year, we really surged, so to speak, and resolved as many as 470 issues in that 3-month time frame. And since the surge ended, we have been working towards a Volta 2.4 release. Again, in a 3-month period, we have still maintained a very good surge because of the processes developed and the expertise developed during the surge. And the idea behind this is that we are working towards this MVP 1.0, where the 3 operators involved, AT&T, Deutsche Telekom, and Turk Telecom, and they've been saying that, okay, this is a set of tasks that we need to get done in order for us to move into production. So MVP 1.0 task completion was the order of business in Volta 2.4. It's still unreleased. It should be released in a couple of weeks. We are going through the QA cycles. There was also a late request to upgrade Kubernetes and Helm. This request came in late, so it's delayed the 2.4 release a little bit. But so as you can see, there are a few remaining tasks to get us there. All right, so that's the progress that we have made through the last 3 months of 2019 and the first 6 months of this year. So looking forward, I want to give you a glimpse of all the things that are happening. So first of all, Volta 2.4, as I mentioned, it should be released within a couple of weeks. And its main idea was this, the remaining tasks, get that towards this completion of MVP 1.0. So at the end of the search, these were the remaining tasks that you see in black on this screen. And then the update for Volta 2.4, as you can see, most of those things are done. So just to give you an idea, highlights of the Volta 2.4 release, and together with that, because as I said, Volta is not independent software, it's an SDN project. It has a dependency on an SDN controller. So at the same time that we release Volta 2.4, we also release a version of ONOS and the applications that Volta uses on top of ONOS. So to give you an highlight, so it is really going to be the first release with full support for all 3 operator workflows. We already did that during the search with AT&T and Deutsche Telekom's FTTH workflow, but this one we have also included the Turk Telecom workflow. Majority of that work involved the use of multicast and multi-tcont in the PON. And so if you want to learn more about that, in the ONF Broadband Spotlights on-demand content, I encourage you to look at SN and Ozge's presentation about multicast and SEBA. So that's definitely a highlight of this release with full support for all 3 operator workflows. We also have in-band control of OLTs, thanks to excellent work done by Radisys and Deutsche Telekom. So the picture that I'd shown of SEBA had the OLTs in the control, in the central office, telco central office, but that doesn't have to be true anymore. The OLTs can now be remote from the central office and managed in-band. And that's great because it lets you go deeper into the network, even closer to the end user. We also have GPON OLT support. Most of the work that we've been doing so far is with XGS-PON, but in this particular release, we have GPON OLT support specifically from EdgeCore, together with ONUs from Circom. We have ONOS app clustering. So basically what that means is that, in the pictures that I've shown before, ONOS can be run in a cluster, and that requires the ONOS apps that Volta uses also to be running in a cluster. And there are many, many scale improvements across the full stack that we have gone through, and I'll talk about that in a bit. And as I mentioned, we have this upgrade for Kubernetes and helps that came in, this request came in late. We're still working on it, but it's going to be part of the 2.4 release. Okay, so what is going to be the focus area beyond Volta 2.4? Beyond Volta 2.4 for the rest of the year. We're going to work a lot on test automation because it's really the core functionality that enables the SEBA and Volta to go into production. And we have several pods that we use for various purposes across the world. And as you can see, the progress, when we first started out during the surge, when we were establishing all of this infrastructure and the automation behind it, we had very few tests, and now with the Volta 2.4 release, we're going to have over 100 tests that run nightly to verify that all the work that we are putting into SEBA and Volta is stable and doesn't break things, right? And I expect this number to keep growing. Also, we have this continuous certification programs where vendors like EdgeCore and Circom that are already part of it, you know, as we keep doing releases of Volta and ONF and SEBA, we ensure that their equipment is still certified for each release. So it's a continuous certification. And you know, just from seeing the number of bugs that have been resolved over the last 6 to 9 months, it's just clear that you know the work that we're putting in, even though really it's an uphill task, and it's all paying off. So if you want to learn more about the challenges of taking open source software to production readiness, working with multiple teams spread across the world, I do encourage you to watch Suchitra, our ONF QA director presentations on this. Also, we will be working on scale and performance. As I had mentioned before, we have met our initial MVP 1.0 targets of this stack, working with 2 OLTs and 500 ONUs on each OLT. But there is much work that still remains. We don't want to stop here. We want to achieve our ultimate goals, ultimate scaling goals. And so there is work to be done to understand how much CPU and memory we are consuming to support a single OLT with say 1,000 or 2,000 ONUs. That is work that we are going through right now. We also want to improve the stack, right? So there are parts of the stack where, for example, we can make some significant improvements to the performance. But ultimately, despite the improvements to the performance, there is always going to be some bottleneck where beyond which improving the resources is not going to help, and that's where we want to get to a multi-stack approach, so that a SEBA pod can scale to many OLTs and many thousands of ONUs. So this is also something that's going to be a focus area for us in this coming in the rest of this year. So if you want to learn more about that, I again encourage you to visit and see Matteo's presentation on how we test, scale, and how we make improvements based on what we are measuring on a nightly basis. Okay. There's always new features also that are going in. For example, one of the things that I've mentioned was we are looking to improve the stack itself. And one of those improvements is a move to Golang for parts of the remaining parts of the stack. So again, here is a presentation that I encourage you to look into from Adtran. There is work that needs to happen in terms of software upgrades and also troubleshooting tools. That's a focus area for sure. As we move into production, there has to be ways where you can debug or at least have tier 1 support through troubleshooting tools in the field, and a number of other features. Another thing that's also not just about the Volta stack, but then looking beyond the Volta stack and so into more SEBA-like things, is work on what we call device management. So Volta does PON management, but device management is where you're actually looking at the box and worrying about the CPU and the temperature within the box and the memory consumption within the box. So it's like device management or box management. And what we're doing over here is that we are working on this API, sort of a standardized API, which can then be used by different vendors for different OLTs to create the device management layer that will meet the needs of this API. So for example, someone like EdgeCore can use Redfish underneath, or someone like Adtran can use netconf Yang. But regardless, the operator's NEM components will be able to use this standardized API for device management. So that's something that we are also working on. Now beyond Volta, again, BNG aspects, there's a lot of things, there are a lot of ways to implement the BNG user plane. There's a few that I've mentioned over here. But what's very important is that in this disaggregated model, you want the BNG control plane to have a common API across all of these user plane implementations. And not only that common API also must be able to program a common model of the pipeline model for forwarding. So that common model can then be translated, because the internal pipelines of all of these devices are very different. So that's also something that we are working on in the TASN project. And if you want to learn more about that, I encourage you to look at Carmelo's talk towards the next generation BNG CUPS API. And then one final thing that I want to mention is that, yes, we've been working on this stack, concentrating on this part, but now we're looking at beyond that part, right? And so looking at these interactions between the OLT and the switch, how to use multiple NNI ports, how to lag them, how to do failover, and so on. So with that, hopefully I've given you a taste of things that we're doing in Volta, improving the stack and testing it, making sure it's ready for production, and also looking beyond Volta into other parts of the stack in terms of device management and BNGs and lags and so on. And that's the kind of work that we will be doing for the rest of the year. But none of this would really be possible without the efforts of ONF and all the companies involved, as you saw in the brigades, the community. And really, it's time to recognize some of the, the stellar contributions that have come in over the last year. We've done this before last year at ONF Connect, and we want to continue that tradition and recognize really the great contributions that have come in. So first of all, I do want to mention that, there are some folks who we recognized last year for their immense contributions, and we continue. Those contributions are major and have continued this year. That includes Girish Gaudra, Matt Jonaret, Ken Nursimulu from Siena, and Matteo. And so congratulations again for the multi-year contributor award to these folks. And then I also want to recognize some contributors over the last year, outstanding contributions from Scott in managing the brigades, the Volta FCAS brigade and his contributions to the stabilization brigade, Barak for his work in multi-TCON, as well as the BAL brigades, Kent in the stabilization brigade, working on Volta core, simplifying the Volta core, also doing a lot of code reviews, which, it's an underappreciated and a thankless job sometimes, but Kent has been really masterful in that. Jason from EdgeCore for all his work in the BAL brigade and his support for the EdgeCore OLTs. Essen for her excellent contributions in the multicast brigade. Suchitra for all the work that we have done in our test automation. And I do encourage you to look at her presentation. And Hardik from Infosys for the work that he has done really across the stack and also in the test framework. So congratulations to everyone. Thank you. And with that, I am happy to take any questions that anyone. Timon?
Saurav, thank you. That was terrific. So we do have at least one question I'll share with you, but I want to encourage others. There's a Q&A button at the bottom of the screen. Feel free to enter questions here, and we'll try to address them both now and at the end of the more formal presentations. But a question I see here, Saurav, is just around scalability, and how much testing has there been done with physical ONUs and virtual ONUs? Sort of what scale have you reached?
Yeah. So by its nature, we don't test scale with physical ONUs simply because we don't have infrastructure to test with, say, 500 or 1,000 ONUs. So what we have done is we have built this simulator called BBSim. And one instance of BBSim can emulate a single physical OLT and up to 1,000 physical ONUs, right? So it's all simulated. And the beauty about BBSim is that the stack, the software stack that you've seen, ONOS and Volta and the Volta southbound adapters are completely unaware that they are working with the simulator as opposed to physical OLTs and ONUs. The reason is because we use the same interface southbound from Volta with the simulator as well as with the physical OLT, right? So nothing changes in the stack. And so we have been very successful in using BBSim across this entire Volta ONOS stack to root out many scalability bottlenecks. First, they were in the ONU adapter, then they were in the Volta core, then there are parts in the ONOS apps, then we're back into the OpenOLT adapter, and so on. So we are at the point where this, as I mentioned, the single stack has been successfully shown to work with 2 physical OLTs with 500 ONUs each. And we've really been working on scale for the last 3 or 4 months. And we wish to continue working on this. I encourage you to look into the presentations from Matteo and Holger about the improvements that we have done on scale for this stack using BBSim.
Terrific, good, thank you very much. So I think we'll transition now in the interest of time. And though I do see one question here about operators that are using SEBA and Volta, so that's almost a perfect transition question because we're going to transition to Turk Telecom now. But I do want to point out, Saurav is mentioning a number of presentations by others. Those are all part of this virtual event, and they're all available for on-demand download, and we will share pointers to how to get to that content towards the end of this webinar.